So our next task is to make the appropriate adjustments so that our game works using the paddle class. And we just went ahead and defined the paddle class, and we defined the update method. And then we also created our paddle objects. But if we hit run, our program doesn't run. Because if we scroll down, we have like the ball algorithm still using the old paddle variables, right? And also our blitting is using the old paddle variables, the paddle variable that held the surface and the paddle variable that held the rects. So let's make those changes right now. The first thing would be this red, right? We're not using p1_rect to hold the rect of the left paddle. We're now using our left paddle variable, which is containing our left paddle's the object or the instance of the paddle class. And then we're also using the right paddle object, which holds the instance that's going to represent the paddle on the right side. And if we go up into the paddle class definition, you can see that we have our width, our height, our speed, our image, and our rect. So that means, like, for the way that I like to like visualize this, because if you can't visualize the code, then you're gonna have a hard time kind of manipulating code and understanding what's going on. So just a heads up that like visualizing what's going on with whatever model makes the most sense to you is the way to a deeper understanding of what's going on. And so the way I like to kind of think about it is like, this guy is an object. It's not just a single variable, it's a set of variables. So I think of it like a burlap bag of potatoes, and it has the word left paddle like stamped on it. And then there's another burlap bag of potatoes with the word right paddle stamped on it. And then this bag of potatoes has a bunch of variables in them, which are width, height, self, or speed, image, and rect. And then this burlap bag here also has its own set of variables inside of the bag with height, speed, image, and rect. Okay, so that's kind of what I visualize in my mind's eye. And even inside of that burlap bag, we have an object here, right? The rect is an object. It is a collection of variables. It's the x position, it's the y position, it's the left, the right, the top, the middle, the bottom, it's center x, center y. So this also is a bag, so maybe you can think of it as like a little backpack inside of the burlap bag that has a whole bunch of variables, right? It's an object of type rect, right? And if you really want to talk about it, like image is also an object. It's an object of type surface. And surface has like a width, a height, it has a color, it has a image, it has x position, y position. No, it doesn't have x position, y position. I'm sorry. That's held in the rect. But the point is that the surface returns an object of type surface that we're holding inside of this image variable, right? So this is an image, and this is an object, and this is also an object. So it's like a bag inside of a bag, right? But anyhow, so we got these two burlap bags, right? Left paddle, right paddle. And so when we're down here, we don't want to use like these individual variables that we had earlier in our main. We want to use our burlap bags that contain those variables. So then here we're going to say left paddle dot rect dot right. Okay, and so rect has x, y. It has, what else does it have? It has a height, a width, and then it also has right, left, top, bottom, right? So we could say right. And then over here, we're going to say left paddle, or maybe I could just like copy this, left paddle dot rect. Copy that, paste it right there. And I'm going to come over here, paste it right there. Come over here, paste it right there. And then I'm going to do the same thing, but this time for the right paddle, right? So I'm going to say right paddle dot rect dot left. Whoa. Let me just get it right there. Copy, paste. And then I will paste and paste. And okay, so now that looks good. There's no red lines at least. And then here on the screen blit, if you remember, blit takes in the surface as the first argument, and then it takes in the rect, the corresponding rect as the second argument. So if we look up here in the paddle class, we can see that the surface is contained in the image instance variable, and then the rect is contained in the rect, right? So we can go ahead and come down here, and I'm going to paste in right paddle dot rect. That's not right, right? Here I want to do the surface, which is in image, and then right paddle dot rect. I'm going to do the same thing over here, but I'm going to use my left paddle dot image and my left paddle dot rect. Okay, so that looks good, and let me go ahead and run it, see if it works. Okay, so it does work, except can you see what's happening over here? Is we have our left paddle, which is moving, and now I'm going to hit my up arrow, and that is actually my right paddle, but he's in the wrong position. Okay, so why is he in the wrong position? Well, the reason is because when we create our right paddle, right, we give it all these values, and the last value that we give to the paddle class is the X position, right? So we are, first of all, we're giving it the same X position, which describes the right side of the left side of the screen, right? And then second of all, when we come up here to the constructor of the paddle, we're not using that X position, right? So we need to use this X position, and so where are we going to use it? Well, does it have to do with our width? No. Does it have to do with the height? No. The speed? No. The image? No. Right? The surface? It has not. The surface has nothing to do with the position of the sprite. Surface is simply the image of the sprite, right? The height and the width and what it contains. The rect, yes, dude. Rect is all positional information, right? So then this xpos I'm going to use right here, because the first argument for the rect constructor is X position, Y position, and then the next is the width and the height. And then using that data, everything else can be calculated, like center X, center Y, top, bottom, left, right. All of those things can be calculated using these 4 pieces of data. So I'm going to use xpos here, right? Then I go ahead and save it, and then I run it, and I get the same thing going on, right? The same thing. Why? Because back down here when we're constructing our paddles, we are using the same X position. So that's bad. So what I'm going to do is I'm going to do win underscore width, and I'm going to subtract, let's do 40, which is the width of the paddles, times 3. I think that's right. So let me run it now. And now we're good, right? So I got my left paddle, I got my right paddle. They're all both in the right location. And the reason why is because when it comes up to construct the paddle, the rect's X position, the left paddle's X position on the rect is the left side of the screen, and then the right paddle's X position on its rect is the right side of the screen. So then when it comes into the game loop, it's going to come down here to the screen.blit, and it's going to blit the left paddle's image at the left paddle's rect, whose X position is on the left side of the screen. So then bam, it's on the left side of the screen. And then it's going to blit the right paddle's image at the right paddle's rect, whose X position is at the right side of the screen. So then bam, this guy goes onto the right side of the screen, right? So that's how this is all kind of connected, right? I think that's about it. Yeah, that's about it, right? So we got it working, and it works fine using our paddle class. Oh, let's go ahead and finally check to see if it bounces off of the paddle. Yes, it does, right? So there we go.